Lesson 6.3.2. What techniques can I use to solve trig equations? Solving more complex trig equations. The focus problem for this section is 6-117. We're going to take a look at solving an equation that involves both cosine and sine and is on the domain of 0 to 2 pi. So a big strategy that we need to take a look at here is, can we make this equation involve only sine or cosine so that we can simplify and solve? So everyone should be thinking, what could we think of to substitute or replace in this equation so that we can get it to be only sine or cosine? And one big identity is the fundamental Pythagorean identity. So if you recall, that looks like the cosine squared of x plus the sine squared of x equals 1. We should all have that memorized by now. So let's solve this for either cosine squared or sine squared. Which would you think we should solve for so that we can substitute into the equation that we're trying to solve here? Well, I would vote for solving for cosine squared of x. So if we go ahead and subtract sine squared of x from both sides of the equation, the identity, transform the identity to cosine squared of x equals 1 minus sine squared x. We are ready to substitute. So now let's rewrite, and in place of our cosine squared x, we'll place 1 minus sine squared x. So here we go. 2 times 1 minus sine squared x equals 0. Now let's simplify, clean this up a little bit. We'll distribute the 2. So we've got 2 minus 2 sine squared x plus sine of x plus 1. Oops, that's supposed to be 0, equals 0. And we can combine some like terms here, 1 and 2. We'll combine 2 sine squared x plus sine x plus 3 equals 0. Now let's go ahead and divide through everything by a -1, because it's no fun factoring something with a negative in the leading coefficient. So that brings us to 2 sine squared x minus sine x minus 3 equals 0. Now, believe it or not, this is a quadratic in standard form. We've got our squared term, our x term, and our constant. In order to factor this, it might be easier to substitute u into our equation for sine of x. So if we rewrite this using u in place of sine of x, we've got 2 u squared minus u minus 3. Now we can factor. To 2, we'll go ahead and put 2u in the first set and u, and this will factor to plus 3 and actually minus 3 and plus 1. Now with the zero product property, we've got u is 3/2, or u is equal to -1. Now we can substitute each of these values back into u and solve for x. So for our first one, we've got 3/2 equals sine x. Now 3/2, that's greater than 1. Can we get a value of the sine of x that is greater than 1? It's actually outside the unit circle, so this one is not a viable answer. So we can skip that one. Let's try the other. Sine x equals -1. So at what value is sine of x equal to -1? Well, we can use our unit circle and take a look at where sine on the y-axis is equal to -1, and that's all the way down here. That is 3 pi over 2. So x is equal to 3 pi over 2. Now, if this is tough, using the unit circle, another way to quickly sketch out and think of how to solve for sine and cosine is to do a quick sketch of the cosine or sine curve. In this case, it's sine. And we know and can quickly sketch that sine begins at 0, goes up, back down, and ends back here. So what's the total period of sine? It's 2 pi. Halfway, pi. Here, 1, or pi over 2. Here, 3 pi over 2. The amplitude is 1, so we reach all the way up here at 1, and all the way down here to -1. So, where on the sine curve are we equal to -1? That would be right here at 3 pi over 2. Okay, I hope that went well.